Welcome to qnawire.
You have a rocket that's being fired up with a certain force while it is ejecting a certain mass here at a rate of 1.5 times 10 to the fourth kilograms per second. And this mass here is moving at 2.6 times 10 to the third meters per second. So the exhaust is moving with these kind of numbers. And this thing weighs, so the rocket initially, MI initially was 3 times 10 to the sixth kilograms. So the first thing I want you to calculate is the thrust on this thing. So we know that from the chapter 9 equations, the force that's provided by this changing mass here is, so it's given by the following equation. So the thrust from any exhaust gas that's acting on a rocket is actually the speed of the ejected mass times the change in mass itself. So this is the rate at which the mass is being ejected, and that's the rate of change of the mass of the rocket. So essentially, so we have all these numbers now. So we know that the rate of change of mass is actually that here. So that's 1.5 times 10 to the fourth. And then we know that this ejection velocity here is just 2.6 times 10 to the third. And notice that this will give you the total thrust that's given. So that's around 3.9 times 10 to the 7 newtons. So notice that this equation here is essentially telling you that by ejecting a certain amount of mass from the back here, you actually force this rocket to go forward or up. So you can clearly see that there is some kind of so there is some change in momentum that's coming from this ejecting mass here. And if you look at this equation carefully, you will notice that over here, this is a force here. So the thrust is some kind of net force that's acting on it, and that is being multiplied by velocity, a mass, and being divided by some time here. So notice that this is just a fancy way of writing that the impulse is equal to some change in momentum that happens on the rocket, and that impulse comes from the thrust. So we can actually come up with that as our solution. So now we want to find the acceleration of this thing as it leaves the launch pad. So we know that initially it has this mass. So if the thrust is pushing it upwards, there should be, again, the weight of the object pulling downwards. So if this is moving up, it means there's an acceleration going upwards here. And that acceleration, so mass times acceleration, should be equal to Ft minus mg. And again, we've already computed the thrust. So that's 3.9 times 10 to the 7. And then we subtract the mass of the rocket, mi, multiplied by g, which is 9.8. And then we divide this whole expression by mi to get that over here. And what you see is that the acceleration that you end up getting is about 3.2 meters per second, per square second over here, since it's acceleration.